Hi everyone, this presentation is about the wire yagi antenna designed and analyzed as part of the antenna microwave circuit design course. We simulate the antenna at 0.8 GHz and studied its radiation, gain, impedance, efficiency and power characteristics. This work is done by our team members B. Harshit, Nagapraveen and Gurdeep. Now coming to the next slide. Wire yagi antenna. At 0.8 GHz, the yagi antenna operates close to its resonant frequency. It consists of one divine element, one reflector, and one or more directors. Due to mutual coupling, currents are induced in the parasitic elements. The parasitic elements is the reflector carries a lagging current, the director carries a leading current. Because of this power phase difference, the radiation is strong in the forward direction, the radiation is weak in the backward direction. The result is end-free radiation, which is key feature of yagi antenna. Next slide. 2D gain plot. This 2D gain plot shows how radiation varies with angle at 0.8 GHz. We can clearly see a dominant main lobe is the forward direction, very small back radiation. This confirms the antenna radiates mainly toward the director side. It has a high front to back ratio. The antenna has good directivity and forward gain. Now next slide. 3D gain total. The 3D gain plot gives a complete three-dimensional view of radiation. Here we observe a single strong forward lobe and a very low side and back radiation. See, energy is highly concentrated in the direction. The antenna has high directivity. It is suitable for point-to-point communication. Next slide. This is a return loss and also called S11. At around 0.8 GHz, the curve shows a deep minimum. This means very little power is reflected back. The antenna is well impedance matched. The antenna is operating at a resonant frequency. Next slide. Input impedance. It is a Smith chart. This Smith chart shows the input variation. At 0.8 GHz, the impedance point is close to the center of the Smith chart, which indicates the impedance is mostly resistive. Reactive components are minimal. The antenna is near resonance and well matched. Now coming to the next slide. Radiation resistance. At 0.8 GHz, the radiation resistance is approximately 22 ohms. The antenna effectively converts input power into radiated power, and mutual coupling from reflector and director modifies current distribution, and overall radiation efficiency and directionality are proved. Now coming to the next slide is 2D directivity explanation. This plot shows the directivity pattern at the operating frequency. Maximum directivity occurs in the forward direction. Deep nulls appear in unwanted direction. This confirms highly directional behavior and strong end-free radiation characteristics. Now coming to the next point. Next slide. Polarization ratio. The polarization ratio indicates the type of polarized and a high polarization ratio in the main radiation direction, very low cross polarization. This means the antenna radiates predominantly linearly polarized waves. Signal quality is improved with minimal polarized loss. Now coming to the next slide. Incident power. This plot shows the incident power which remains constant at -20 dB. This indicates a fixed input power is applied to the antenna. Any change in performance is due to antenna behavior, not input power variation. Next slide. Accepted power. The accepted power reaches a maximum near 0.8 GHz. This means at a resonance reflection in a minimum, the maximum power is observed by the antenna. Matching is best at the center frequency. Now coming to the next slide. Radiated power. The radiated power plot also peaks near 0.8 GHz. This shows most of the accepted power is converted into radiation. The antenna radiates maximum power at resonance. Now next coming to the total efficiency. This plot shows total efficiency. At 0.8 GHz, the efficiency is maximum, which indicates minimal conductor and mismatch losses. The antenna performs best at its design frequency. Thank you for your time. This concludes our presentation on the wire yagi antenna.